Hi everyone, it's Tracy Capriotto. I am here in Canton, Ohio at the NAPA EV Ready Training Center. So I'm so excited to be here. I'm going to do a couple little things with some EV stuff, and I have Bill Weaver here, who is the head trainer for NAPA Autotech, and he's going to teach me a couple things about electric vehicles.
Well, we have everybody down doing some podcasts, so we figured we'd bring Tracy out to the garage and kind of introduce everybody in the world to some basic safety, I think, is what we're going to go over. So I brought her out in order to make her safe. She hasn't gone through all the EV training that we expect everybody to go to, so I'm going to be her guide on the side to make sure we don't make any mistakes. We're going to go over a little bit of personal protection equipment. We're going to let you guys see one of the meters that we may use. This particular one is from our friends over at Pico. And then we'll talk about her getting some safety equipment on. So the first thing we're going to do to make sure we're safe, this particular meter has the ability to put out 250, 500, or even 1,000 volts at a time. So if we're going to work with voltage like that, I want to make sure that your hands are free of grass, grease, oil, or anything like that. And then we're going to have you put on some lineman safety gloves. Okay. The gloves that we use for EV training are going to be Class 0 gloves. They're going to be a set of 3 gloves, a cotton to put on the inside to keep your hand from being moist. There'll be a rubber that goes in the middle of it, and then we're going to cover them up with a protective leather layer. So just judging by your hand size, I guess you're somewhere around what we would call a 7. So okay. The first thing we're going to have you do is don the cotton gloves. And those are just to make sure that your hands will be able to work back and forth. Now, if we were going to let her do live exercises, one of the things we'd have her do is remove all of her jewelry, the watch, and everything to be conductive. So we're just doing the exercise so you guys can see the gloves and how things are going to work.
Now, what do you mean this is a 7? So are there different sizes based on?
Absolutely. Always different sizes. Your hands run a little bit smaller than our average mechanic, so we're going to go down to a size 7 glove. They're labeled up here. These gloves are going to be very important. It's your last line of defense that you have between you and electricity. So this means we have a red label here. We have a Class 0 glove. It is a size 7. We'll discuss the dating in a little bit, but we'll just make sure that you get these gloves on. So you'll see very, very daintily sized hands. They're not going to fit me, but I'm guessing they're going to fit you just fine. So I'll have you go ahead and slip on our gloves.
Okay.
Now that's a decent fit.
Can she do surgery now?
I'm telling you, we might be able to get her into some automotive surgery.
What is the highest number glove size?
The highest number of gloves that we carry here are an 11, but they go the whole way up to 14. So if you have massive Sasquatch hands, and we do have a Sasquatch that works for us, we're able to fit him with gloves. The average that I see in the technicians, I tend to go between a 9 and a 10. Most technicians are between a 9 and a 10. And I'll tell you, the glove sizing, just like shoes or pants, guys, it really depends on the manufacturer what you're going to get. In fact, the day after a weekend of, let's say, a lot of salty foods or something, I may tend to wear a 10 as opposed to an 11.
I wonder what size Brian Pollock would use for gloves. We'll have to ask him. I don't think it's a 7.
The last thing we'll do is put on our leather protector. Now, the manufacturer of the gloves and...
Oof, these are...
Yeah, so
light.
Now you're starting to see, we'll get another set on for you. So now, I used to take my fingers and I'll go like this to make sure they're down here, because with these gloves on, I still expect you to have enough dexterity to work some of the meters and maybe even do a little bit of disassembly on the car. Now, before we go any farther, let me explain to you the actual truth about the gloves. Our goal is to get these gloves off as soon as possible. The only electrically safe work condition that we can have as a technician is when we make the system inert, when we power it down. It's our job as a technician with our PPE on to verify that the voltage has gone away. Wherever the manufacturer of this particular car told us to verify, that's what we're going to do. As soon as we, the technician, have verified that we have the absence of voltage, we've proved that we are safe to work on it, I'm going to take these gloves off, I'm going to put them right back in their bag, and I'm going to set them aside until the next time I have to work with high voltage, which is on this car, probably going to be when we power it back up. So the protection aspect of it, getting gloved up, and being able to have the dexterity in your fingers is something you have to pre-plan. When we work on electric vehicles, there's a lot of times I'll spend time telling people there's a lot of pre-planning. Because now if you have to cut a piece of tape to tape over something, those gloves have to come back off, and then you'll have to put them back on. So the process of forethought, when you work on an EV, it becomes very regimented. Before I go over here, I cut my tape band-aids because when I remove an electrical connector, I want to tape over it.
Okay.
So I'll walk up to an EV with a bunch of orange tape badges all over me, and people will ask us in the class, why would you do that? Well, I'll let you put on the gloves. Now tear off a piece of tape for me, see how that works. So if I have them here, and it's all pre-planning, it's the way that we change our day. So just with the PPE, to be able to grab the meter and know that you're safe and insulated from the 1,000 volts that it's able to put out on one of these cars, I think would be one of the first lessons that I want to teach everybody. When we go through EV training, honestly, the first day, that's what we do. We spend an inordinate amount of time on safety and prepping you to make sure that you're going to be safe to work on these vehicles. Every time that you put the glove on, you should test it. We have several different ways to test them. I have an inflatable tester. I also have one that works off of shop air that will inflate it to about a 0.5 PSI, and there's also a float ball that will tell you if there's any small leaks. Would you like to see a glove testing demo?
Let's do it.
Awesome. Let's get it all set up. We'll be right back.
We're testing gloves now. Okay, put this on.
It's a little tight. Stretch it over there. Remember, it's a rubber glove and it can take it.
Okay.
Now we'll place it over in our holder and we'll go ahead and turn the glove to the inflate position. Now, if I had this type of inflator, and we'll let that one go ahead and run, this is a manual inflator, we would simply go ahead and pump that up the same way we would with a blood pressure cuff if you've seen that before. Now, this glove, I can pump it up. We want to go to about 1.5 times the size that it is out of the container, so we'll pump that up so we get a nice big flex out of it. And then with this tester, we would go ahead and seal it off, and we would watch for deflation, and we'd move the glove around to see if there was any problem. On this tester over here, it's actually a little bit of a better test. If I look down at my flow meter, we'll see that that flow meter, just like on your EVAP machine, has not dropped down to zero flow, which means there is still air going through this glove and exiting somewhere. It's not sealed. If I turn the glove around, Tracy, you'll see I've circled the spot. And if you take your finger, you can barely feel the air coming out of it.
Yeah.
Okay, so if I turn this over to decay to watch it go ahead and see if it continues to leak, the glove will get to a certain size, the hole will self-seal, and it won't be a leak here anymore. You won't be able to feel it. So with
What do you mean it'll self-seal?
Well, because the rubber starts to contract around the
when
hole,
it
it tends to self-seal. So if you put your finger over there now, you can barely feel it. Once it gets down to about this size, not inflated 1.5 times, that leak is actually gone and it will not show up anymore.
Wow.
So the testing of the glove becomes important. Some people will tell you that in a pinch, they will actually tell you to cuff the glove and roll it up. But what are we missing? This whole bottom part that we're looking for air leakage and we can't see it expanded. So I really changed my mind about glove testing once I got the flow meter one available for it as opposed to the pump up. Listen, it's the last line of defense between you, your body, and high voltage electricity. And hopefully we'll never have to use the gloves for the safety feature that they are, but we never put PPE on for our best day. We always don personal protection equipment for our worst day. I hope you never experience your worst day, but that's why we wear PPE.
So when these start getting dirty, should you change your gloves then?
Absolutely. People don't think about that, Tracy, but any kind of dirt, debris, gas, grease, or oil that's on that glove could be conductive. Even to the fact where we have our dedicated insulated tools, I want to make sure that I clean these off. And when I clean my tools, honestly, I do it with soap and water and Dawn because it's the safest and it doesn't leave any kind of residue. I don't want this plastic, the insulator itself being attacked by any chemical, brake clean, or solvent that I might use. And the whole idea is when these tools are all together, they're 100% insulated, that even if that drops down inside of a battery pack, there's no chance of electrical connection between the tool itself. So between the ratchets that we have, the sockets, everything, once we put them together, it completely hides any metal surface on the outside.
Now, do the gloves have anything on the packaging saying when they get dirty or anything you should be changing them? How
Well,
would someone know that if they aren't piecing it together?
if we
they just get
come to
dirty?
training, you should have been trained on it. The glove manufacturers, there are a lot of rules and regulations that go with gloves. How long you can go before you have to send them to a laboratory to have them recertified. For instance, the gloves that we opened today for you, from here on, your 6-month clock has started. So even though you're going to test them every day, 6 months from today, those gloves have been deemed that you have to send them back to a manufacturer or a testing facility in order to test them. At that point, they will take the rubber glove, they'll wash it really good, they'll immerse it in a water bath to make sure it's clean, they'll dry it off, and then they'll stick an electrode inside of it and an electrode outside of it and make sure it will insulate up to the 1,000 volts, the 10,000 volts, the 5,000 volts, whatever the class of gloves is. The gloves that we use says right here that we have, you want to read out our classification? Should be a class 0 glove.
Class 0, max use volt 1000 V AC.
So 1,000 volts AC. So you are protected. We chose this size glove. Now the gloves go the whole way up to 40,000 volts for an actual lineman up there. So the class gets higher. We, in our industry, have deemed that class 0 gloves, because we're around that 400 to 800 volt marker, these gloves should be adequate for us.
Who tracks the timeline, the 6-month timeline?
Right.
That is a personal responsibility. There are manufacturers, and I think Cintas has a program that will do a 6-month glove exchange for a larger shop, where they will come in and exchange all your gloves at one time every 6 months and test them out. Other than that, what we do is we offer a set of gloves for a PPE, and we send it off with the technician when he leaves here. But the gloves that I accumulate, that Dave and myself use, I'll get a batch of them, and then I will send them out and have them done at a 20 glove or 30 glove batch at one time. And they'll send back, depending on how we took care of them, it's probably 80 to 90% will pass. They're not like they fail immediately. However, not wearing your leathers over the top of them, getting solvent inside of them, improper storage. You saw the glove that we were pumping up was kind of oxidized on the outside. These are a natural rubber product, so heat and ozone degrade them. So when we're done with our gloves, we're going to take them out of the leathers, we're going to put them back in that cloth bag that we had, and we're going to put them in the bottom of the toolbox where we can keep them in the best environment.
Don't want to leave them somewhere in the sun by accident.
Not at all. We don't want to leave them where anybody can pick them up and use them for solvent gloves or dishwashing gloves, or I'm going to get something dirty, so I'll wear these gloves.
So
it becomes,
after 6 months, you send it, they test them, and then they send back what are still fine gloves.
Viable gloves for another 6 months, and they'll print a new date on the outside here that'll tell you it was tested. So you should be able to, if you keep track of them, look at your gloves and know about when you're supposed to have them. I would advise everybody to have 2 sets of gloves to start with. You're going to have an assistant. Anytime that you work on an EV, I want somebody that's gloved up next to me in case something horribly goes wrong, so I have backup to help, and you have your PPE on as my backup. I also want to make sure that when I send my gloves off to be recertified, I have a set of gloves to be wearing at the same time. So when it comes to the investment of PPE, some people really sometimes frown on the cost of it, and I never understood that.
And is that personal protection equipment?
Personal protection equipment, acronym across the, of
Too
every
many
industry.
acronyms. Okay, gloves are tested, ready to go.
So let's go put you on a meter and go see what we can do. So here we are, Tracy. We've got a small stator out of a Ford transaxle and a large stator. Stator meaning it's the stationary part. We call it stationary. We're going to have Tracy try to lift this.
Oh my God.
So guys, what we're looking at, outside of here is a bunch of laminated steel layers, and then it's wound with a bunch of copper, and this is what makes our 3-phase motor. Now, we're going to have you glove up, and what we're going to do is test to see if we are insulated between our copper windings and this steel. We should not have copper attached to the steel. Even though it's wrapped around it, this wire is encapsulated in a lacquer or a coating on the outside of it. So technically, even though it looks like all that copper is touching one another, it's not. That would be an internal short. So what we use this copper for is to make a big giant electromagnet to make that rotor assembly rotate inside depending on which one of these wires we put electricity to.
What is this made out of?
This is an insulator cotton with a wrapping that goes on the outside of it, and it's basically to hold all the copper together. Remember, as we start to accelerate this vehicle, these copper windings are being pushed with magnetic force, and there's actually movement that occurs inside of them. So we try to bolt them or bolster them and attach them with glue and fiber and string as best as we can to stop that movement. The more we move, the more we can break through that insulating layer that I talked about, and we can cause some partial internal shorts. In fact, that's what we're going to check for, is an internal short in one of these legs. So I'll have you go ahead and get your gloves back on. Do you have your cotton?
Yep.
Okay.
So an internal short means there's something that's not connected, or?
No, a short would mean we're connected to something we should not be connected
Okay.
to. So an internal short to me would mean that this copper wire now has continuity or is attached to, which it's not supposed to be, to the steel part.
So the copper is not supposed to touch the steel?
No, the
But it's
copper is
just-
supposed to make
it's
an
just
electromagnet.
Wow, so it's two things put together that should not be together, and then that's,
100% isolated.
okay.
Now, on our picometer, what we're going to do is we're going to dial this up to an insulation test. And when you, or me, one of us, pushes this test button, we're going to send over 500 volts out through these tips. The idea with this meter is trying to blow electricity, trying to overcome the insulation between the wire and the steel. And if this device was working correctly, that should never happen. We should not be able to overcome it. And it would tell us that we either had an isolated circuit, a good circuit, or a bad circuit.
You're only supposed to do this with gloves on, right?
Because we are over 500 volts at this point, every manufacturer I've out there seen that has a meter will tell you PPE is mandated. I'm far enough away from it that I'm just going to push the button and you're going to be okay while you hold that.
I feel like the kid in Jurassic Park that's like holding on to something and poof.
Did you clear the landing zone behind her?
Who's got the hook?
I also
There,
feel like
actually, the hook is hanging on the wall because that is part of the PPE and the service equipment that we have in the facility.
now, if you liked playing the game Operation when you were younger, this kind of makes sense.
I'm glad you brought that up. Would you grab my voltage proving unit for me hanging on the front of that volt? So in order for this meter to tell me that it's okay, what we've done is we've built a 1 mega ohm resistor into a voltage proving unit. So the first thing we're going to do is we're going to do a test not on here, we're going to do it on a known fixed resistance. We're going to push the button and we're going to see how the meter works so you understand what correct is and what correct isn't. On top there, this little orange device we had one of our guys 3D print it, and inside of it I put a 1 million ohm resistor.
Now, what if I touch these together? Is anything going to happen?
Well, if we touched them together, we would have very little resistance. In fact,
Okay.
go ahead and do that, and we'll see what happens. Go ahead, touch the leads together. And if I push the test button here now, it says that it's got only 0 ohms of resistance, and the 500 volts that I put onto the circuit, none of that voltage is there because we have a dead short. If we were testing a component, that would tell us the component's short. This test that you just did tells me the meter can figure out if we have a short. This tester pushes out, in this setting, 500 volts.
That's great.
And the whole idea is, unlike our traditional ohm meter that's checking for resistance in a circuit, we're literally trying to force electricity out of a circuit to see if it leaks. So because I know that this part should not be connected to this part, I'm going to take one lead and introduce 500 volts into the coil, and hopefully none of it leaks down into the metal part. So if we do it on our mega ohm tester, let's get them down inside of there again. Make sure we got good contact. So with good connection, you'll see on the meter, I put 500 volts into the circuit, or 532 into the circuit. It was set at 500 volts, so we're very close to what we put out. And the resistance across the two leads is 963 ohms, which is very close to the 1 mega ohm resistor. So that proves that my meter can read correctly. Because we have a tolerance on the resistor, it's never going to be exactly perfect. So now we're going to do the same test, but we're going to do it with our two leads here. So I'll make sure that our leads are hooked up correctly, and we'll go ahead and push our test button one more time. So this one has over 168 million ohms of resistance between the copper and the steel. That is well within the spec of being a good. It's an isolated, a very, very good stator. Let's look at this one. This one came out of a problem vehicle. We'll do the same test. We'll go from the metal section to the copper section. If I push test now, you'll see that all my voltage has gone away on the screen and I have no resistance. It is a dead short inside of here. So this has melted the copper inside of it. The insulation that used to separate the copper from the steel is now touching.
Oh, okay.
And this meter found it by forcing in this case, 500 volts through the copper wire, and that 500 volts leaked out into the steel.
So kind of how we tested the gloves for leaks, you're kind of testing this for...
That's exactly what we're doing. We're trying to make enough electrical pressure to force it out where it wasn't supposed to be. We can take that same meter, and that's how we would find a bad cable. We would try to see if we could force electricity to go through the conduit and leak out of the insulator or leak over to a ground point. Remember, the whole thing about high voltage is the high voltage section is always isolated from the car itself. It's as if we took a big mag light and stuck it in your car. The mag light doesn't share a ground with your car. The mag light doesn't share a hot with your car. It's just inside of your car. It's a separate electrical system, and that's what high voltage does on a car. One of the opportunities we have at EV Ready, I have all these meters, and I'll let the students use several of them to figure out what buttonology is different, what one's comfortable, and what one they like the best.
Awesome. Well, thank you so much, Bill. I've had a great time here at the NAPA EV Ready Training Center. We're going to be back here in June for a full week with Matt Fonzo. We might have some fun with him. I don't know.
Maybe. Matt's a fun guy, so.
Thank you so much, and we'll talk to you later.